In this video, I'm going to show you a new and original method for how to do combined means questions. I'm hoping to show you why my method is better than other methods I've seen people using. Let's have a look at a question. We've got 25 students in class A and 15 students in class B. All 40 of them sit a test. We've got the mean for class A is 81%. The mean for class B is 87%. We want the combined mean of the two classes. Let me show you first of all the method I've seen people using in the past. So I'm going to split my board in half. You definitely need a calculator for this first method. So the way I've seen people do this is by taking a kind of weighted mean approach like this. So we've got 25 students in class A, so we would do 25 multiplied by the mean of class A. So that's this 81%. So we do 25 times 81. Then we look at B. So we can switch colour for B. Well, we've got 15 in B, so we need to add 15 multiplied by the mean of B. 87, and we divide that by 40, total number. So 40 was our total number of students. This works fine, so let's check what we get. 25 times 81 plus 15 times 87 over 40. I've got here 83.25. That works fine, there's no problems with this. I'm going to show you why my method is better, I think, though. And it's really about having a conceptual understanding of what's going on. So for my method, what we need to do is we're drawing a number line. And at either end of our number line are going to be the means of the two groups. So class A, the one with 25 students, that was the slightly lower mean at 81%. So we can add on here. This is class A at 81%. Class B is going to be at the other end. So B has got 87%. And the way that my method works is you know your mean has to be somewhere between the mean of class A and class B. So we're going to guess our mean looks somewhere around here. And I used a word earlier, I said the means balance each other out. This is what my method's all about. So we're going to draw a kind of pivot point or fulcrum in the middle of these two. And we're imagining these two groups are on a seesaw. So they're both kind of pulling down with a weight, but their weight is balanced by the mean in the middle. Our next step here is to think about the weights of the two groups. So group A has got a weight according to the number of people in it. So for group A it's 25, and for group B it's 15. That means that A is pulling down with a larger force because there's more people in group A. So if you wanted to make these balance, well then we need the pivot point to be a bit closer to A to balance out that larger force. The way we decide on the distances is by the ratio of people in the groups. So let's think about the ratio of group A to group B. It's 25 to 15, and we can simplify that down as 5 to 3. This means the ratio of the distances must be 3 to 5, the inverse of the weights. So I'm going to draw on my seesaw a bar model out to show this ratio. So 1, 2, 3. On this side, make a note that's 3. On this side we need 5. So 1, 2, 3, 4, 5. See, all of these parts of the ratio are equal. Altogether then, we've got 6% between these two. 6% on our number line is equivalent to 8 parts on our ratio. We'd like to find one part, so we need to divide by 8 here. Likewise, if we divide our 6% by 8, we should get 0.75%. That means each of these small parts on our ratio represent 0.75%. So we can add this in here, 0.75, 0.75, 0.75. If we want to find the mean then, we start at 81%. We've got 3 lots of 0.75. That gives you 2.25%. 81 plus 2.25 would give us 83.25%. That is the same as the other method, so we're definitely right. I think this encourages a more conceptual understanding of balancing means though.